Hey guys, welcome to the beginning of Statistics, Chapter 1. This chapter is relatively light, it's just some basic vocabulary that you'll need to know for the rest of the course. So throughout the entire course, there's two main groups of people that you'll always need to know about. So one is going to be your population and one is your sample. So these are two distinct groups of data that you need to know the difference between. So the population is the entire group of people that you want to know about. If you want to find the political alignments of people in America, then your population is all of the people in America. Or if you want to find out whether students on a college campus are in favor of some new policy, then your population would be your students on the college campus. On the other hand, you have your sample. So most of the time, you probably don't have the money nor the time to interview every single person in your population, right? So that is why we have samples. And these samples are groups that you take out of the population and get data from, and based on your sample, you can make guesses about what the population looks like. So in the case of the college campus, because our population was the entire student body, and we didn't want to go ahead and interview everyone in the student body, we just got 20 randomly selected students out of the entire student body. So our 20 students is our sample, and hopefully we can use the information that we get from these students to make guesses about our population. Similarly, if our population is the entire United States, we could take samples of maybe 100 people and ask about their political alignments to make guesses about all of America's political alignments. So your variables are the information that you're getting from your samples. So it's what you're interested in finding out about. If you want to find out people's approval of Hamilton on a scale from 1 to 10, Hamilton the musical, then that would be a variable. And it could also be height, GPA, favorite color. It's just whatever you're finding out about. And these variables are all data. And you can split these data into two main groups: your quantitative data and your categorical data. So quantitative is what it sounds like, quantities, so you're talking about numbers. So this is all data that can be expressed as numbers, and these are numbers that it would make sense to take the mean of and then find the standard deviation for. So again, examples of this would be your height, your approval of Hamilton on a scale from 1 to 10, and then your GPA. On the other hand, we have categorical data. This can also be called qualitative data, and it's just data that can, one, either be put into defined categories, or just everything that isn't quantitative. So the most generic example would just be favorite color. So there is a special case for categorical data called an identifier. So this is where this value is completely unique to a person. For example, most identifiers come in the form of your legal document numbers, so your driver's license ID, your social security number, etc. So anything that is completely unique to a person. This is still categorical, but this time there's just lots of categories, so one category per person, because an identifier is unique to one person. Within quantitative data, we also have another subdivision into discrete data and continuous data. So discrete data is data that can be counted. So you can think of it this way. You have a little robot and it's just sitting there and churning out every possible outcome, or it's counting your data. So for example, if you're going to count the number of stars in the sky, you can just imagine your little robot counting out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the most obvious way you can tell that data is discrete is if the data values are only limited to a certain type of number. For example, if the data can only be whole numbers or integers, that is discrete data. But if it goes into the decimal places indefinitely, then you have continuous data. So this cannot be counted because our robot is just going to get stuck on an infinitely large number because there are infinite possibilities for the data to take. There's an infinite possibility of numbers for the data to take on. So one example would be the average weight of a group of people. Every time you see the word average, you automatically know that this is continuous data. Any averages is continuous. Because as you continually average people into the group, then your weight range is going to shift around and it's going to go into these really long decimals that your little robot cannot get out. So the main idea that you always have to keep in mind when telling the difference between categorical and quantitative data is, would it make sense to take the mean of this data? Although it seems like the lines between categorical and quantitative are pretty clear-cut, they do tend to blur sometimes, and this is the best way to keep yourself in line. So here's some practice with it. We have 6 examples here. I'll give you a minute to pause this video and work these out for yourself. If not, here we go. So first of all, we have gender. Can gender be expressed as a number? No, so we automatically know that it's not quantitative, so it has to be categorical. Now what about number of people on Earth? You see the word number, so you automatically know this is probably quantitative, because you can count out the number of people on Earth, and it would make sense to take the standard deviation of numbers of people. So this is quantitative. But let's go a step further and ask ourselves, is this discrete or continuous? So number of people can only be a whole number, because we cannot have negative people, nor can we have decimal people. So that means that the number of people on Earth is a discrete variable. Next we have address. This one's again a little bit iffy, because you can't really think of a category of addresses, right? But at the same time, it's definitely not quantitative either, because your street, the name of your street is not a number. So we can go with categorical for address, solely because it's not quantitative. But then again, let's go a step further. Is this an identifier? Is your address completely unique to you? The answer is no, because you might be living with your parents or roommates, so therefore address is not an identifier. Next is your social security number. So I mentioned this before, but social security number is completely unique to a person. So that means that this is automatically an identifier, and because it's an identifier, that makes it categorical. So even though it says number here, this is still categorical. So why is that? Even though it's a number, that doesn't mean it would make sense to do math on your social security number. If you went into a room, got everyone's social security number somehow, would you be sitting there trying to find the average social security number? No. You're not going to go find the mean social security number or the standard deviation of some social security numbers, because there's no really mathematical meaning behind it. So that's what makes it categorical and not quantitative. Quantitative is numbers that you would actually do math on. So next we have the cost of groceries. So cost of groceries is obviously a number. You would do math on your cost of groceries, so average cost of a trip to grocery store, etc. So that would be quantitative. And is this discrete or continuous? So this one's a little bit harder because you know that the cost of groceries can go into your decimal places, but there's only a set number of decimal places that your cost can go into. So generally speaking, we only go to 2 decimal places when we talk about money, so your robot can count that out. So 1 cent, 2 cent, 3 cent, 4 cent. So that creates a set category of numbers to go through for outcomes of cost of groceries. So that makes it discrete. Last one is average number of students in a class. This word average here should immediately set off alarm bells, because I said before, as soon as you see the word average, you should know that it has to be quantitative and then continuous. So one thing to keep in mind is to always pay attention to the question context, because sometimes, depending on the context, your variables might actually change between quantitative or categorical. One great example of this is age. So age is a number, right? So it would make sense to take the average age of a classroom or something, so that would definitely make it quantitative. But if you're running an experiment and you just want to group people into middle-aged, young adult, and then elderly, then we clearly have set categories, right? So you always have to pay so much attention to your question context, because when we grouped people by age, we made categories. But when we need to perform math on the ages, that's quantitative. So question context is everything in statistics, and so always read the questions. So that's it for your basic statistics foundation. Thanks for watching. Hope you learned something. Peace.